Good morning. Good morning, sir. Today we are going to see about the DC motor starters. Okay, now. So this is the case study how the DC motors can be started. How the DC motor can be started safely, and also we have to protect from the various conditions. Okay. So may I know what is this? The 3-point starter. So this is a 3-point starter which is used to start which type of DC motor? So in DC starter there are 3 types. There is a 2-point starter, 3-point starter and 4-point starter. There are 3 starters will be there. So this is a 3-point starter which is used to start DC shunt motor. Which is used to start DC shunt motor. If it is a 2-point starter, it is used for series motor. And 4-point starter can be used for shunt motor as well as compound motor. Okay. So here there are 2 main protective coils are there. There are 2 main protective coils are there. So this is one coil and this is another coil. May you know what is the name of this coil? Overload release coil. This is called OLR. Overload release coil. And this is called no volt release coil. This is called no volt release coil. No volt release coil. So may you know why it is named as 3-point starter? Why it is named as 3-point starter? So line, field, armature. Okay. So in DC shunt motor, shunt means the field winding and armature winding are connected in parallel. Field winding and armature winding are connected in parallel. So there are one incoming, and there are 2 outgoing. One is current through field, another is current through armature. So it requires 3 terminals. Incoming, 1 incoming and 2 outgoing. So 1 income is called line and 2 outgoing. One is called field and another is called armature. So that's why it is named as 3-point. There are 3-point. 1 incoming and 2 outgoing. Okay. So now the incoming from the EV, incoming from the supply, which is connected with L. Just connected with L. Just connected with L. So now you can see the back side. You will see the back side. There will be a connection will be there. If you are connecting the connection with the L, okay, now the internal connection directly goes to the handle. Directly goes to the handle. So the current will flow through this handle. The current will flow through this, and the handle touches the stud. So how many studs are there? 1, 2, 3, 4, 5, 6, 7. There are 7 studs are there. Okay. So out of 7, the first one is dumping. The first one is dumping. It is called off connection. You can see the back side. So only gold will be there. So there is no outgoing connection. There is no outgoing connection. Okay. This is an open circuit. This terminal will be open. So now the main is on. The current will flow through this handle and it starts with off position. It will be off position. Step number 1. So there is no outgoing current. There is no outgoing current. Okay. Now the handle is moved slowly. So before that, before going to the step number 1, it will be connected in OLR coil. Okay. So from L it goes to the OLR coil. From the end of the OLR coil it goes to the handle. Okay. So L. Then after that it goes connected to the OLR coil. From this OLR coil it goes to the handle and it will be there. Okay. So in between the 2 shunts, there will be an armature resistance. This is called starting resistance. The starting resistance will be connected between the 2 studs. Okay. So we across these 2 studs, some amount of resistance, here some amount of resistance. So there are some amount of resistance will be connected. Okay. So at this terminal, at this final terminal, this is called run position. First one is off position and last one is run position. From this run position, directly it goes to the armature. Now the L is here. From the L we are connecting L. From L to OLR to handle, and handle to flowing with the starting resistance, and the final step is connected with armature. Okay. So one thing. And second thing, this first step will be there. No, second one. From this second, it is connected with OM is connected with NBR coil. Lower release coil. Second step, which is connected to NBR coil. After that, it goes to the field. After that, it goes to the field. So now, at this first question, there is no outgoing. There is no outgoing to field and armature. Now the handle is moved to the first shunt. Okay, now. So what about the field current? The current which is goes to the field, whether it is high or minimum or maximum. Current to field maximum, because the current which is entering into the handle directly it goes to the NVR and field. NVR at the field. At starting, the NVR is having the high amount of maximum amount of current. Maximum amount of current. Am I right? So, and what about for armature current? This current which is entering into the several amount of resistance. So, huge amount of resistance will be connected. So, in the armature, less amount of current will be there. Now, it is moved to the next step. What about the field current? Whether it is increase or decrease? Now, this current will return back to the first step, then it goes to the field. So, if you are moving the handle, what about the field current? Field current reduces because the current which is coming back, so we are connected some amount of resistance, so that it goes to the field. So, field current is gets decreasing. And what about the armature current? Increase. So, if you go for the final question, what about the armature current? Directly it goes to the armature. The armature is high. And what about the field? Decreasing. Okay. So, while flowing through this NVR, the coil is getting magnetic. The coil is getting magnetic and it acts as an electromagnet. So, this coil will act as an electromagnet. This electromagnet will attract this ion gas. That will be an ion gas. So, the ion gas will be attracted. So, we can be able to hold the handle. We can be able to hold the handle. So, the motor is get started. So, the main objective of using this starter to limit the starting current. To limit the starting current. Suppose now the power supply is low. There will be an interruption in the power supply. So what will happen? What will happen? Okay, now the output is not released. Within a fraction of a second, again the power supply is come back. So what will happen to the motor? Now the output is not released. While entering the power supply, the output is not released. Within a fraction of a second, again the power supply is came. Okay, now, so this handle is a maximum question. The full current initially will be given to the motor, so it may create spark inside the winding. Because of spark, the winding is getting heated, so that the coil will burst. Okay, the coil is getting dead. Okay, so if that's a power supply, there is an interruption in the power supply. Okay, so any current will flow through this coil? No, there is no current. If no volt, if there is no voltage, there is no current here. So the coil is getting demagnetized. If the coil is demagnetizing, it is unable to attract this and soft iron. Soft iron of the handle. So with the help of spring, there will be a spring. With the help of spring, again the handle is bringing it to the original position. The handle is bringing it to the original position. If again the power supply is stayed, again we have to manually pull the handle to its right position. So until the motor will not. So we have to safeguard. We have to protect the motor at no load condition. That is no voltage condition. Okay. Otherwise it may damage the motor or something. Suppose if the motor is overloaded. If the motor is overloaded, the maximum capacity is 25 amps. If the motor exceeds more than apart from 25 amps, above 25 amps, this coil is getting magnetized. So it acts as an electromagnet. This electromagnet will attract this soft wire. Attract the soft wire. If this soft wire is getting attracted, so there will be an interconnection. These two connections will be interconnected here. Okay. So if this is short circuited, the no voltage wire is getting short circuited. If this is short circuited, it getting demagnetizing. So unable to hold the handle. So again it is the original tool. So we can able to protect the motor from the low volt condition as well as warm load condition. Okay, so this is mainly to protect the motor as well as to limit the starting current at the time of starting. That is the main thing. Okay, so the main drawback of this starter, if I want to increase the speed, I want to reduce the field current. At a certain instant, if I am reducing the field, Okay now. So the field current is reduced as the current which is entering into the lower to coil also gets decreased. Okay now. Is unable to develop the sufficient amount of magnetic field. If the field current is low, the field current is not sufficient to produce the magnetic field. So to attract the handle. So automatically unable to hold the handle. So if I am trying to increase the speed above the some speed above the rated speed like 3,000, 4,000, 5,000 like that, if I want to increase automatically release the handle, so the motor will disconnect. So if I want to increase the speed above the rated speed, definitely we have to go for 4-point starter. This limitation can be eliminated in the 4-point starter. So again, so this is the case study why we have to use in the DC motor starters. Okay, any doubt is there?